Can we analyze a pore network? And yes, and this is one of the, I believe, very common analysis people do with the rocks. So let's take a look at a couple of examples. So we're going to use this packed sand as an example. This is just a raw CT scan image. The first step of a pore network analysis is to segment the void space like this. So this is the segmented void space. And then once you segment this void space, you can start calculating different things. For example, you can look at the distance map. And the distance map show you where the center location is between two grains, and you can trace them. Or you can measure the thickness of the void space to identify large void space, like this one is over 200 microns, or narrow spaces, maybe this one is 30 to 50 microns. Now, this is just a tiny patch we're looking at in 2D, but you can visualize this in 3D for an entire core and remove the grains to see the void space color-coded for the size. Now, this void space can be seen as a pore network. So let's say that this is part of the void space. Now, we're going to say that those large spaces are pores, and we can measure the size of the pores. And those pores are connected with those narrow throats, and you can measure the throat size too. And then when you look at the void space this way, you can start looking at this as a pore network and analyze things like path length. So this image is showing the path length between different pores. The blue chains represent a relatively short distance between two pores. Green is a little bit longer, and this one is over 500 microns to go from one pore to another. And again, you can always look at the entire pore network in the cylinder without the grains. So this is a regular path length. You can also calculate the direct distance between two pores as a straight line. And at this point, we have two different kinds of distance measurement for two pores. One is the round-around way to go through the void space, and the other one is the straight line. Now, we can calculate the ratio between those two and get tortuosity. And tortuosity can be mapped to the original image like this. So in this image, blue chains now represent relatively straight path between two pores, low tortuosity. This red one is high tortuosity. That means that you have to go kind of long, round way to go from one pore to another. Another way to look at the pore network is to visualize the connectivity. So in this case, you're looking at how many pores are connected to each pore. This one, for example, is a dead end. So this pore is connected to just one another pore. This one is connected to 3 more, and this one is connected to 6 pores.